So in this video, we're going to be covering the AP exam free response questions for AP Precalculus. These are sample FRQs that can be found on the AP Precalculus course and exam description. You're going to have to pull up the questions yourself because I can't copy and paste screenshots of the questions into my recording software because my computer is a piece of garbage. So you're going to be on your own for that. But I'm going to be walking you through all the questions of the sample FRQ. It's really easy to access the sample FRQs. Just search up AP Precalculus course and exam description on Google, and then pull up the document, and then scroll down to page 174, and you'll be there. Uh, as always, you can pause before each question to see if you can do it yourself. So let's begin. So part A, we're going to be doing part A of the FRQ. As you can see, a graphing calculator is required for this section. So you can pull out your graphing calculator or you can use Desmos, which is what I'm going to do. So let's look at the first question in section A. So A1 or A of I, whatever. Let's say A of I. A of I is asking us to define h of 5 as a decimal approximation or indicate that it's not defined. So decimal approximation just means that you're going to round to 3 decimal places. You're going to round to the thousandths place. AP wants you to round to the thousandths place for some reason, so just do that, I guess. The first thing we're going to do is write down h of x. So h of x is a composition of function g and function f, and this is another way to write it. I'm going to be using this equation because I honestly think that's just simpler to use in this scenario. So they want us to find h of 5. So you're just going to plug in 5 for x. Okay, so now we need to find f of 5. So based on the table, f of 5 is equal to 34. So h of 5 is equal to g of 34. Now what we're going to do is plug in 34 for x in the g of x equation. So your setup should look like 34 cubed. Let me write that 4 better. That looks like not a 4. 34 cubed minus 14 times 34 minus 27 over 34 plus 2. So you just plug that into your calculator, and then the answer you should get after rounding to 3 decimal places is 1,077.806. So h of 5 is equal to 1,077.806. Okay, so now moving on to AII. AII is just asking us to find the value of this. So this is really simple. What this question is asking us is what value of the function f gives us f of x is equal to 4. So this is the same as f of x is equal to 4, and we're trying to find x. So we're going to look at the table for this, and you can see that f of x is equal to 4 is on there, so it is able to be defined. And then you can see above that is a 3. So f of 3 is equal to 4. So the inverse of f of 4 is just equal to 3. So now we're going to look at B of I. BI. Question BI. So what it wants us to do is to find all values of x as decimal approximations for which g of x is equal to 3. So this is also really simple. All you have to do is plug in the equation for g of x into your calculator. So plug in x cubed minus 14x minus 27 over x plus 2. Plug that into your calculator. And then if you're using like a physical graphing calculator, like a TI-84 or something. Let me write this better. Hold on. This garbage. If you're using a TI-84 calculator or something like that, you can also plug in y is equal to 3 and use the intersect option on your calculator to find the x value. If you don't know what the intersect option of the calculator is or where it is, you can just search it up on YouTube. It's pretty easy to access, but I can't say it off the top of my head. It's just kind of something that I can do when I have a calculator. So you can do that, and you'll find that there is a value of g of x as equal to 3. So it is defined. And that value is x is equal to 4.857. That's our answer. And your graph should look something like this, where that straight line is y equals 3 and all the other stuff is g of x. So now we're going to be looking at BII. So BII is asking us to determine the end behavior of g as x decreases without bound. They also want us to write our answer as limit notation. So I'm going to do a rough sketch of g of x first. This cubic looking thingy, this, and then this parabola. It looks something roughly like that. So since we're only focusing on when x decreases without bound, we're just going to read this graph right to left. And as you can see, let me write arrows on this first. This might make it a little, okay. So as you can see, as x decreases without bound, this line right here just keeps going up to infinity. So your answer should be limit of g of x as x decreases without bound, so x is going to negative infinity, is equal to infinity, because this line right here is going up forever and ever. A common mistake that you might have done is only focusing on this section. This section is right here is closer to the y-axis than this section at the top. So you can't use the bottom section because it's less negative than the top section, if that makes sense. I don't know if that did, but there's your answer. So now we're on question CI. CI is asking us to use the table of f of x to determine if f is best modeled by a linear, quadratic, exponential, or logarithmic function. So first step, let's write down the table. So for our first column of values, we have 1, negative 10, 1, negative 10, and we have 2, negative 5, 3, 4, 4, 17, and 5, 34. So to determine what type of function we're going to use, we're just going to focus on f of x. So right off the bat, we can eliminate the exponential function option because you're not multiplying by common ratio for these y values. Like for example, negative 10 to negative 5, you'd have to multiply by a half, but negative 5 times 1/2 is equal to negative 2.5, which is not 4. So we can get rid of the exponential function option. And chances are, if it's not exponential, it's probably not logarithmic. So we can probably eliminate that too. So what we're left with is the linear and quadratic options. So how we're going to determine that is just determining the first and second differences of these f of x values. So for our first set of differences, so negative 10 to negative 5 is 5. Negative 5 to 4 is 9. You have to add 9 and then add 5. 4 to 17, you have to add 13. And then 17 to 34, you have to add 17. And then let's look at the differences between these first set of differences. So to go to 5 to 9, you have to add 4. 9 to 13, add 4. And then 13 to 17, add 4. Quadratic functions are the only functions that have a constant second difference like this. Quadratic functions are the only functions that have just the same second difference through and through and through. So therefore, this can be best described as f of x can best be described as a quadratic. A quadratic. So now we're looking at question CII. It wants us to give a reason for your answer for the last question using the change in the output values of f and the change in the input values of f. So let's cover the input values of f first. The input values of f are just a consecutive equal size interval. So we can start off our answer by writing as x increases over consecutive equal sized intervals. AP really likes it when you use that term, consecutive equal sized intervals. So I will recommend incorporating that into your answer if the question calls for it. Okay, so there's our first part of our answer. And now we're going to be talking about the change in the output values of f. So the change in the output values of f, if you remember, is they have a constant second difference, which what is characteristic of a quadratic function. So we're going to write down as x increases over consecutive equal sized intervals, f of x increases with constant with a constant. Let me write that down. With a constant second difference and the second difference was 4. So with a constant second difference of 4. And there's our answer. So now we're on question 2 of part A. This is the last question of part A. Question 2 is just talking about a year-long study about test scores. It gives us 2 coordinate points, and it gives us a function. So let's look at 2AI. It wants us to use the given data to write 2 equations that can be used to find the values for a constant a and b in the expression r of t. So r of t, let's write down the equation of r of t first. R of t is a plus b times the natural log of t plus 1. And then let's write down the 2 coordinate points that they gave us. So they gave us 0, 75. So the initial start, they had a score of 75. And then 3, 70.84. Meaning at the third month, they had a score of 70.84. So this first column right here defines t, and this second column right here defines r of t. So what we can do is just plug in the coordinate points that we got into the equation of r of t. So what value can we replace in? So, okay, first of all, we're going to use this first set of coordinate points to construct our first equation. So what can we plug in for r of t in this equation with these coordinate points? We can plug in r of t in the first equation with 75. Then we can write down the rest of the equation. Then what can we plug in for t? We can plug in 0 for t. So we have that. That's our first equation. I guess you can simplify 0 plus 1 into 1. That's our first equation. So what about our second equation? We can use the same logic for our first equation to construct our second equation. So now we're going to use this set of coordinate points. So what can we plug in for r of t? We can plug in 70.84 and then write down the rest of the equation. And then we can plug in 3 for t. So we have 3 plus 1, which is equal, then 3 plus 1 is equal to just 4. So there's our second equation. So now looking at 2AII, it wants us to find the values for a and b. So we can use the equations that we used on the last question to find a and b. So first off, let's use this first equation. So the first equation is 75 is equal to a plus b times the natural log of 1. If you plug in natural log of 1 into your calculator, you would just get 0. Natural log of 1 is equal to 0. So we have a plus b times 0. And anything times 0 is just 0. So b is like effectively eliminated. So we can do a and then write the rest of the equation. So therefore, a is equal to 75. That's the first half of the equation. So now let's find b. So we can use the second equation to find b. So our second equation was 70.84 is equal to a, or excuse me, we know what a is. So A, we can substitute it in for 75 plus B times the natural log of 4. So simple algebra, we can subtract 75 from both sides, and we would get negative 4.16. Then we can evaluate the natural log of 4. We're going to round it to 3 decimal places like always. So natural log of 4 is equal to 1.386. I'm going to go up here. Then we can divide both sides by 1.386. I'm going to go up here. So we find that B is equal to negative 4.166 divided by 1.386, which is equal to 3.001. Or excuse me, negative 3.001. So there's your answers. So now looking at 2BI. 2BI is asking us to use the given data to find the average rate of change of the scores. So remember that your average rate of change formula, that I'm just gonna acronymize. I don't know if that's a word. Acronymize, whatever. As a rock. So our formula is just is fx2 minus fx1 is equal to x2 minus x1. So in this case, our x2 is 3 months and our x1 is 0 months. So we would have I'm gonna write down R since the question uses R. So we have R of 3, our x2 in this case, and then our x1, which is R of 0, then 3 minus 0. So R of 3 is equal to 70.84. R of 0 is equal to 75. Then 3 minus 0 is just 3. Plug this into your calculator, and you will get negative 1.387 as your APROC. So now we have 2BII. We're looking at question 2BII. So it wants us to interpret the meaning of our answer from the first question, for the previous question. So our answer to the previous question was negative 1.387. So what does this mean? So remember that average rate of change is basically just slope. So that means that since it's just slope, that means that in this case, the points just decrease by 1.387 per month. So our answer for 2BII would just be from month 0 to 3, the uh, the test scores decrease by 1.387 points per month. There's our answer. So now we're looking at 2B_II. So it wants us to consider the average rate of change from t equals 3 to t equals p, where p is greater than 3. And then it wants us to determine if the average rate of change is less than or greater than the average rate of change from t equals 0 to t equals 3. So in questions like these where they're asking you to compare the average rate of change between two intervals, you're gonna have to rely on the concavity of the graph. The concavity of the graph. That's concave up, concave down. That's what you learned in unit 2, or excuse me, unit 1. So what we can do is plug in our equation for R of t into a graphing calculator, so we know what A and B equal now. So remember that R of t is equal to 75 minus 3.001 times the natural log of t plus 1. Let me move this graph out of the way. So if you could plug that into your graphing calculator, you would get something like this. So remember that concave up looks like this. This is concave up. Concave down looks like that. Concave up means that the rate of change is increasing, and concave downs means the rate of change is decreasing. So based on this graph looks like a really, really stretched out version of concave up. So since it's a really, really stretched out version of concave up, that means the rate of change is increasing. So therefore, our answer is on intervals. The rate of change from the interval 3 to p, rate of change, let me write this better, of 3 to p Jesus Christ, I cannot write. 3 to p is greater than the rate of change between 0 and 3. Oh my God. There's our answer. So this is question 2C. Is talking about the validity of the model after a year. And it says that when the model is invalid when the group's predicted score at the end of the year is at least 1 point lower than the group's predicted score at the end of the previous year. It wants us to figure out the first year that it's invalid. So this seems complicated, but all we have to do is plug in multiples of 12 into t into our equation of R of t. since we figure out what R T of it is. So, excuse me, R of T is equal to 75 minus 3.001 times the natural log of T plus 1. So all we have to do is plug in multiples of 12, since it's asking us the year, and year has 12 months. So you can plug in 12 for T, which is equal to 13. And that's equal to 67.303. And now we can do the second year. So we plug in we plug in 24 for T because it's the second year. So I'm just going to write down R24. And when you plug that into your calculator, R24 is equal to 65.340. You can tell that these two have a difference of more than one. So our model is still valid. So now let's move on to the third year. So we're going to plug in 36, and we would get 64.164. It's still valid. The difference between R24 and R36 is still greater than 1. So now let's do the fourth year. So we're going to plug in 48, and you would get I'm struggling to you would get the 63.321. So the difference between 64.164, or the third year value, and 63.321 is 0.843, which is less than 1. And the model is invalid when it's less than 1, because the model is only valid when the predicted score is at least 1 point lower. So therefore, the first year that the model is invalid is the fourth year.